Today we are going to discuss how to integrate Spring Boot microservice with Graal using Docker. So we are not installing Graal in our local system. We are only use Graal for the build of a Spring Boot microservice using Docker. So here is the configurations. The first configuration is a pom.xml. This is a normal parent entry. This is the metadata related information. And Graal is always used for the 3 or 3 plus version for the Spring Boot. It is not compatible with the 2 version. And the second change is we need to add this spring.aot.enable 2, which is ahead of time compiler for the Spring. And at the last, we need to add only this plugins area. This is a plugin for the building our Spring Boot application. Now I am adding this into my profile section only when the native is activated. The plugin will be loaded. Uh, this is the first component. Now the second component is Dockerfile.native. We need to manually activate this file instead of Dockerfile. We will discuss about later. So first is that from it will download the Graal environment for the Java 17. We are using as a builder. So this is nothing but creating the workspace, copy that Spring Boot application, running that Maven command, then native and package command. So and we are just copy that uh, exe- executable file and running it. And this is our entry point, and this is our port. Now the Docker Compose file is same as previous one. For the like the previous video, we need to just add this image name because we are using the native. So this is the image name, and this is it. Other the Kafka and MySQL DB, these are the previous one. So we are not changing anything anywhere. Now in the class section, this is the class section. This is a listener class. Yeah. So this our listener class is just listening to other topic and printing the message. And this service is doing posting the message to that topic. This is simple and config is the same like previous one. This is a 2B I am creating and nothing else. This is a command line runner. Whenever our boot application is loaded, it will trigger the final message. So I think that's it as the component part. Now I'm going to the Docker CMD. So let me check what are the images are available. So currently there are 3 images are available: Kafka latest, MySQL, and Kafka UI. So let's start running that building that native image. So, so this is my command to build that my sample project native. So first time it will take time. Images. You see here, the sample project native is created because first time it will take time because I have already run this command, so I it didn't take much time to load. So I'm just starting containers. So if you see all the containers are created, so let me check logs. This is Test message sent, and this is final message. My listener is perfectly working. If I will make the postman request as well, the event page is properly listening. And this is my Kafka UI. The number of messages is four. Sorry, two. We create this message. I send again the number of messages. Now I want to show you the standard image, standard Spring Boot jar. What is the size of this and what is the size of our Graal image. If you see the images is 104 MB and it will take the disk usage 431. So now I'm starting the standard Spring Boot jar. So to do that, I need to do some small changes. Suppose I'm this. This is a comment it out. To do that, I'm just creating this plain package. This is how we are normally doing to package the Spring Boot application. So my jar is created in the target folder. Explorer. Now let me showing one to four images is one container is showing. Now let me down this. So all the containers are down. So I'm starting Docker. This is normal setup without draw. If you see here, my Spring Boot latest app is created. It's calling Spring Boot. And again, I'm hitting the request. Let us go. Now, when it goes, now here is the catch. If I do this, this is the size of my native Spring Boot project, and this is the size of my standard Spring Boot project. So the crawl is very useful to create the cloud native applications, to reduce the billing or to create the lambdas. So because the JVM is not part of that crawl, it is just directly compiled with the AOT and create that machine code. So this is the today's setup. Yeah. So let's discuss about the problems. So basically, only one problem we are facing while creating that file, the native file. Our Docker is required much more RAM and processor. So we just need to add the extra configuration for the WSL. To do that, just open this your user in the folder, and you need to add this .wsl config file, and then adding these three properties: memory, processes, and swap. So basically, this is the RAM and processor, and this is extra memory. We are querying for this Docker. This is only the problem when we are trying to build the image. I will delete this. Delete so this is deleted. So change this to start again the native. I need to change here and local compose. I will uncomment this line and make this forward. And load the Docker. Because the Dockerfile.native is present inside my simple project, not in a target. For target, we need for the standard Spring Boot application, we need to go to the target. Here, with the Dockerfile, we are just building that and that we are running this. It will take, so I have deleted this native file, native image file. So it is just trying to create again. So it will take 10 to 15 minutes. Only first time it will take. Once the image is available, it will not take the time. So the build is completed and it took these 900 seconds to complete this first time build. And second time I also run that build and it took no time to build that image. So this is for today. Thank you for watching. Please like and subscribe. Thank you.